Okay, we got to interfaces, which is one of my absolute favorite topics. In this section, I'm going to talk about what is an interface, how to declare and implement interfaces, and then I will explain how interfaces improve the testability and extensibility of your application. So what is an interface? An interface is a language construct that is similar to a class in terms of syntax, but is fundamentally different. Let's take a look at the syntax first. So here is how we can declare an interface. Instead of using the class keyword, we use the interface keyword. And note that in .NET, all interfaces start with the letter I. So wherever you see a type that starts with I, that represents an interface. It's a convention. But unlike classes, interfaces do not have implementation. So you see here, we have a method called calculate. That is simply a declaration. It doesn't have a body. It doesn't have curly braces. Also note that interface members do not have access modifiers. So here we don't have public, private, protected, whatever. Now you may wonder, why do we need a construct like that? Well, in simple terms, interfaces are used to build loosely coupled applications. That is an application whose components are not tightly related to each other. Which means making a change in one of these components is easier and has less or zero impact on other components. Let me use an analogy. Think of the concept of a restaurant and a chef. We can say a restaurant needs a chef with certain capabilities. By that definition, we can fill that role with anyone. Anyone who has those capabilities can fill the role of the chef for that restaurant. So the dependency between the restaurant and the chef is loose. If something happens to that chef, like he gets sick or he decides to move on to a different job, we can fill that role with someone else. Now, in contrary, if we said a restaurant needs John as a chef, that means we are very dependent on John. If something happens to John, if he decides to not to come to work, then the restaurant is in trouble. So this is a definition of a tightly coupled dependency. The restaurant is tightly coupled, tightly related, tightly dependent on John. Now, I use this analogy to explain that when building software, we want our classes or our components to be loosely related or dependent on each other. So if we decide to make a change in one of these classes, it has minimal or zero impact in other classes. Take a look at this picture. Here we have two classes, order processor and tax calculator. In this UML diagram, you see a dependency, as demonstrated here, between order processor and tax calculator. In C# terms, that means order processor has a field or a property that is of type tax calculator. Now, this is an example of tight coupling between order processor and tax calculator. If we make a change to this tax calculator here, it may affect the order processor and subsequently any other classes that depend on order processor. Now, we use interfaces to reduce this coupling. How? Well, we can change this picture to something like this. So instead of order processor being dependent on tax calculator, it's going to be dependent on an interface. That is iTax calculator. An interface, as you saw earlier, is simply a declaration. It's not a concrete class. It doesn't have code. Its methods do not have a body. So as long as we keep that interface the way it is, as in like we are not going to remove any of its methods or change its parameters, it's not going to have any impact on the order processor. Now, if we decide to change the algorithm for calculation of tax, we can create different classes that implement this interface here, and that would have absolutely no impact on order processor. If that concept is new to you, don't worry about it. I'm going to show you exactly how it works in code. Interfaces are extremely powerful, and once you really understand them, you're going to fall in love with them. So in the rest of this section, I'm going to explain how interfaces help improving the testability and extensibility of your application. So thank you for watching, and I'll see you in the next lecture.